Let's do a quick experiment. If I asked you to try to remember all of these letters in a set amount of time, like everyone, you'd find it practically impossible. But if those same letters are broken into chunks, it becomes significantly easier. This is because each of these are now recognisable as things you know. Instead of processing the individual letters, your brain only has to process each chunk. PTSD becomes one thing rather than 4 letters. The 24 items to process becomes 8. If we group the chunks into categories, it becomes even easier. This is because the working memory has a limited capacity and is only able to process comfortably around 4 items, and not the 7 plus or minus 2 notion you may already be familiar with. This of course has implications for the way you design curriculum sequences. The primary recency effect presented by Sousa supports this idea of working memory limitation. The amount of downtime or reduced concentration in an extended learning sequence becomes a real worry. Essentially what's happening is that over the course of the presentation of content, the working memory begins to fill towards capacity. Once full, incoming content is battled with to the point of cognitive overload. This has large implications for your content delivery design at this stage of a presentation. The recency effect restores some concentration, perhaps because of a shift in attention as the student realises the end is coming. To counter this, Sousa suggests the downtime is used as practice opportunity, getting students to do something with the presented content. When this happens, the amount of overall downtime is reduced. John Sweller's work on cognitive load theory is remarkable and is neatly summarised in this ratio. By the way, he got his PhD at Adelaide University. When there are greater than 4 items to process and the long-term memory is not able to support the processing, the ratio turns against the student's capacity to maintain concentration. So, how do we prevent cognitive overload? Further evidence that chunking works is Chan and Meissner's work on test-potentiated new learning. In this research, they argue that retrieval in between learning tasks improves learning outcomes. In application, this means that when we design a series of teaching moments, interleaving them with student active moments is likely to improve the processing of each teacher chunk. Essentially, what's being proposed is that as the working memory is brought to capacity in each chunk, the student active section then helps the content move to long-term memory, thereby refreshing the memory to be able to process the next chunk.